Hi everyone, it's Mr. Rowe here. Hope everyone's doing really well. I've been experimenting a little bit with these screen capture videos, so I thought I would try to do a screen capture video lesson for you for this unit. This is the last lesson. The next lesson that says Trig Applications Part 3 is just one question, but we're going to be looking to do an online assignment. You'll probably get it either tomorrow or Saturday, and it'll be due early next week. So I'm going to work through these examples just like we would in class, and I think this is a good lesson to go through because it's going to have both the sine law and the cosine law, I believe. So let's get to it. So this first example, David wants to go from Toronto to Paris, but his flight has stopover. Distance from Toronto to Paris. All the information is on the diagram here. So when you're deciding what formula you're going to use, you have a couple tools in the toolbox. You have SOHCAHTOA, but that's going to be for just right angle triangles. You have sine law and cosine law. And the criteria for using sine law is you need to have an angle such as this and a corresponding side. That's what's going to make up your ratio. So I'm just going to label this A, B, and C. So if you have that, if you have an angle and its corresponding side, you use the sine law. And if you don't, you use cosine law. That's pretty much the criteria. So if you're given just three sides, you'll be using cosine law. Or if you're given two sides and the angle that's inside, you would use the cosine law. But if you have this side and corresponding angle, you're going to go ahead and use the sine law. So what does this question want me to do? How much further did he travel than if he took a direct route straight from Paris? So he's going from A to C. So directly, it would be 6,000 kilometers, but if he goes indirectly, he's gonna go here and here. So we need to find the lengths of this side. I'll call X, and I'll do the other one in red. I will call Y. So that's what they want. They want to know how far is this and this if he does the stopover in London. So first things first, I'm going to go ahead and fill in my missing angle. Anytime I have two angles in the triangle, I can always find the third using the angle sum of a triangle theorem. So you're going to go 180 degrees minus 105 degrees minus 28 degrees. That means that this would be 47 degrees. All right, so now if I want side X, I have the ratio, the angle and its corresponding side. I have this angle, that's going to be enough. So I'm going to go ahead and write out my ratios. So I'm going to find X first. So that's side C. So I'm going to use C over sine C equals, and they've given me side B and angle B, so I'm going to use that as well. So this is an equation with four unknowns. So as long as I have three of them, then I will be able to solve for the fourth. So I'm just going to go ahead and fill in the information. This is side C. Side C is the side opposite or across from angle C. So that's what I want to know. How long is that side? Over the sine of angle C, which is 47 degrees, is going to equal side B, which is given, 6,000, over sine 105. So this note will also be posted with the other completed notes, along with the video. All right, so this is something we can solve. These are just numbers, so anytime you have a proportion like this, you can just solve by cross multiplying. So sine 105 x equals 6,000 sine 47. And then I want to isolate x. So I would just divide by sine 105. And of course, if I do that to the one side, I'll have to do it to the other. And now I can go ahead and solve. So I'm doing this right along with you. That divides out, so we get x equals, and I'll just quickly type this into my calculator, 6,000 sine 47, press the equal sign, divide that by sine 105, press equals, and I got 4,543. 4,543. So the first leg of that trip is 4,543 kilometers. So now I need to find out how long it is from London to Paris. And I'm going to do the exact same thing, except this time I want side Y. So, side A, which I've labeled with a Y. So side A over sine A equals, and again, I could use the information I just found. I'm going to use my given side and angle. So I'm going to use side B over sine B. And just like before, I'm going to fill in the information, cross multiply, and solve. So side A is what I want. That's the distance I'm looking for. Over sine A, so that's sine 28 degrees, is going to equal 6,000 over sine 105. Cross multiply, and you get sine 105y equals 6,000 sine 28. Just want to remind you guys that there's a lot of resources out there. So even without these screen capture video lessons, just go on YouTube. Khan Academy is great, but whatever you're looking for, just say, how do I enter? And this just doesn't only go for math, it goes for any class, and all the information is there for you. So for this kind of scenario to happen, we live in the best technological age to at least handle it the best we can. So make sure you're putting in your best effort. So 6,000 times sine 28, hit the equal sign, divide that by sine 105, make sure your calculator is in degree mode, and you get 2916. Okay, so therefore the total journey is going to be, if I add those, so 4543 plus 2916 So 2916 plus 4543, you get 7,459 kilometers. So that's how far it's going to take if you do the stopover. So just to answer the question properly, it does say how much longer. So if you had gone directly, it would have been 6,000. So really the answer is 1,459 kilometers longer. And then you should probably put a therefore statement. Therefore, it is this much longer. But we'll just move on. I'll have the therefore statement in the post-it note, but I'm going to try to keep this as short as possible. So there you have it. So the next question then is this one. We need to fill in a little bit of information. So he's going to shoot the hockey puck from here to the net, from here to the net. I believe they're giving you the distances to the hockey post. So the goal line is 8 feet given. He shoots a puck to a point that's 10 feet from one and 13 to the other. So he's closer to this point. So this is going to be the 10 feet and this is going to be the 13 feet. And they want to know what angle must he shoot the puck in order to score. So they want this angle. So we have no way of knowing if this is a right angle triangle, so we cannot use SOHCAHTOA. The next thing we would look to use, and this comes from the last lesson determining what formula to use, is can I use the sine law? Like the last question, we're going to look, do we have an angle and a corresponding side? Well, the obvious answer is no, because they don't give us any angles. So when you don't have an angle and a corresponding side, and it's not a right angle triangle, you are going to use the cosine law. So that's what we're going to do. So again, I'll just label this triangle ABC. And there is a modified version of the cosine law formula that will directly allow you to solve for an angle. So if you refer to that note, if you want an angle using the cosine law, it looks like this. But this is just a rearranged version of the original cosine law. So here you go. When you do the assessment, you're going to have all the formulas anyway. But this is what it is. B squared plus C squared minus A squared all over 2BC. So it does matter which side goes in which variable, so you want to make sure you're putting them in the right spots. If this is what I've labeled angle B, then this is side B. If this is what I've labeled angle C, then this is side C. And this would be side A, opposite angle A. So I'm going to fill those in. So B is 13 squared. C squared is 10 squared minus A squared, that's 8 squared. Now, unlike the last question where I kind of did it all in one shot, I'm not going to attempt that for this because putting in your calculator, you could make a mistake. So I'm going to do the top, calculate the top separately from the bottom. So 2BC. So I'm going to go ahead and put in the numerator. So 13 squared plus 10 squared minus 8 squared, you get 205. And you divide that by 2 times 13 times 10, and you get 260. And now we are finding an angle. So anytime you are ever finding an angle using trigonometry, you need to isolate angle A, and it's attached by cos. So the way you undo that, or the opposite operation, you have to use the cos inverse. So you would have seen that in SOHCAHTOA lessons, as well as sine law and cosine lessons. But it's a general rule. Anytime you are finding an angle, you will be using the inverse trig function, which you activate by going second function or shift. So for this one, I'm going to go 205 divided by 260. It gives me a big long decimal answer. I don't really need to write it out. Maybe I will just for demonstration this one time. But you don't really need to write this out. But you get this really long decimal, and you don't want to clear your calculator or round. You just leave this big number on your calculator screen, and then you press shift, and this time we want to use cos inverse, so we're going to go shift cos to activate cos inverse. Press the equal sign, you get 37.9, which I will round to 38 degrees. And again, this is a word problem, so maybe a statement, therefore he must shoot the puck within 38 degrees. And that's about it. So that'll wrap up the first lesson, but hopefully you learned something from this. Be ready for an assessment soon. work on the review, go through this. Maybe I'll assign it tomorrow and then have it due early next week, so I'll give you plenty of time to work on it. I will also give you instructions on how to access it and how to submit it back to me. But again, just generally, I hope everybody's doing really well. We don't know how this is going to end up, but we'll just keep plugging away. And honestly, all I'm looking for is for you to put in an honest effort. Just try your best. Ask me questions if needed. I'll do my best to help. But when I give the assignment out, just try your best, hand it back. So as long as everyone's doing their best, everything should work out. If you're feeling stressed out, send me a message. Let me know what's going on, and I'll do my best to help out. So that's about it. Until next time.